Hello my dear students and my dear friends, we are here to start chapter number 8, plane geometry. It is there in class 10 advanced mathematics. At first we shall take exercise 8.1. In this exercise 8.1, some basic concept or preliminary things are required. Let us take that. Let us consider a circle. Okay. Now we know that angle on the same segments are equal. This is the segment. In this segment we consider some angles, these angles. We said these angles are equal. Angle APB equal to angle AQB because we say that they are angles on the same segment. Okay. Then second concept is required that if we take this circle, angle in a semicircle is 90 degree. This is the diameter. Angle on this semicircle is 90 degree. That is angle APB is 90 degree. We can consider. Then let us consider a circle again. If we consider this chord, you know that this is chord. If we extend this chord on both sides, this is called secant, S-E-C-A-N-T, secant. If we drag this secant in such a way that if this secant touches the circle at a single point, then this is no longer a secant, this is called a tangent. A tangent is a line which touches the circle at a single point. Okay, this circle is constituted by infinite number of points. So in a circle we can draw infinite number of tangents. Okay, then from the center we draw the radius. This line is called radius, you know it. This radius is always perpendicular to the tangent, or conversely we can say that tangent is also perpendicular to the radius. With this concept, let us start now exercise 8.1. Let us move to the board now. Now dear students, before starting exercise 8.1, we need a theorem. This theorem is very essential for completing any question of exercise 8.1. Let us read the question. Here, the angles made by a tangent to a circle with any chord through the point of contact are respectively equal to angles in the alternate segment of the circle, or this theorem is also called alternate segment theorem. So let us prove it. Okay, here at first what is a tangent? Let us take a tangent here. Let us draw a tangent. As we have discussed, a tangent is a line which touches the circle at a single point. Okay, it will touch a single point. So this is P and this is Q, and here the point of contact is A. This is called point of contact. Here we take a chord. You know this is chord. Okay, this is B. This chord, name of the chord is AB. Now what is said, at first we have to understand. Here let us consider a circle. Here we draw a tangent. Okay, this is the center. From here let us take a chord AB. Now what is the meaning of alternate segment? Segment means this is a circle. If we draw a chord, this part is called a segment. This part is called segment. Now there are two segments. This smaller segment and this is major segment. Okay. Now with the tangent, this chord makes two angles, either this angle or this angle. Chord makes two angles with the tangent. You can consider this angle or you can consider this angle. Now when you consider this angle, this is the adjacent segment and this is the alternate segment. Alternate means this word alternate is used to indicate opposite one. This is the angle made with the chord and the tangent. Its alternate segment is this one, not this one. This is the adjacent one. And when you consider this angle, this is the angle made with the chord and the tangent. Its alternate segment is this one, this segment, not this one. This is the adjacent one. Okay. So what is said here, the angle are respectively equal to the angles on the alternate segment. This angle. So this angle, there are two angles here also. This is one angle and this is another angle. Okay. Now this angle will be equal to, if you make any angle, this angle, its alternate segment is this one. For this angle, the alternate segment is this one. Let us make two angles. Okay. So we have to prove that this angle equal to this angle, and this angle, this chord makes angle with this tangent. This angle will be equal to, suppose here, let us take any point. You can join this also. Okay, I am drawing the freehand diagram, it is faster. Okay, so here this angle will be equal to this angle and this angle will be equal to this angle. We have to prove. Now let us name the figure A, B. Suppose this is C and this is D. Okay, now so I am writing from to prove. I am not writing given all this. To prove, what we have to prove? First of all, we have to prove that angle BAQ, this angle equal to this angle. This is angle ACB, and secondly we have to prove that this angle, okay, what is the name of this angle? Angle BAP or angle PAB. This angle equal to this angle, angle AD, this is D, okay, ADB, angle ADB. Okay, my dear students, always in geometry, always you remember one thing, that to prove construction, to prove the what is given in the theorem, we need some construction. So let us take the help of construction. Okay, my dear student, generally I'll take some time to start this. Generally student find it is geometry is very hard, but my dear student, geometry, according to me, geometry is the easiest branch in mathematics because there is no formula here. Then what is this geometry? What is the base of it? Geometry is based on the logic. If you are logically correct, then any proof you can do. Whatever proof, whatever theorem is given to you, okay, that question you can easily solve, but you have to be logically correct. In every statement, after every statement, you have to give the logic. Yes, for this reason I have written. Okay, now what is the procedure? According to me, if you ask my suggestion, according to me, whenever any question is given or any theorem is given or any correlate thing is given, how will proceed geometry if it is unknown to you? From the given part you proceed. At first you do the sum or the theorem or the question or the answer or the solution in your brain at first. As all of you have taken advanced mathematics, that means you are all excellent students, brilliant students. So in your brain you start doing the sum. Okay, you move forward direction. Okay, this sum can be done in this direction. You move up to some extent. After that you cannot move. Then what you do? From the back side you move. Then you join them. This is the technique. Okay, again I am saying, from the forward, from the whatever is given, from that direction you do the sum. Okay, then from the end again you try to do and try to correlate, then you are getting the solution. This is the easiest technique. I always follow that. Okay, if a sum is tough, like if I feel it is little bit different. Okay, so here what is the construction? Construction is that here we take a center. This is the center. From the center, let us draw the diameter. We have to say diameter will obviously pass through the center. This is the diameter. Okay, and this point is joined. This point is joined. Okay, suppose this point is E. Name of the point is E. Okay, let us wrap this part. Let us write the construction. Here diameter AE is drawn, and what is joined? BE is joined. B is joined. Now let us start the proof. Okay, dear students, here AE is a diameter. So angle, what is the measurement of this angle? Can you say? This is the angle in a semicircle. I will give all the hints here. This is the thing. This is A, this is E, this is B. This angle is 90 degree because angle in a semicircle is 90 degree. Okay, here angle AE BE is equal to 90 degree. Okay, now dear student, what is the sum of these three angles? By angle sum property, we can say the sum of three angles is 180 degree. Already, so here, that means angle A plus angle E plus angle B is 180 degree by angle sum property. But angle B is 90 degree. So what is the sum of angle A and angle E? 180 minus 90 is 90 degree. So therefore, angle AEB plus angle EAB plus angle EAB is equal to how much? 90 degree. So this is equation 1 we have considered. Also, we know that in a circle, radius is perpendicular to tangent. Okay. Here also, OA is perpendicular to PQ. So what can write? Therefore, angle EAQ is also 90 degree. Now dear student, can you tell me what is angle EAQ? This is the sum of which two angle? This angle and this angle, is not it? The whole angle is 90 degree. So this plus this is 90 degree. Angle EAB plus angle BAQ is 90 degree. This is angle, relation 2 or equation 2. Now let us measure this is 90, their sum is 90 degree, their sum is also 90 degree. So we can write that they are equal. Okay, from 1 and 2, from 1 and 2 we get, what do we get? We will write this equal to this. Alright, angle AEB plus angle EAB is equal, this is written, and then we will write this equal to this. Angle EAB plus angle BAQ. Now dear students, you can see that this is on both the sides, so let us remove them, or you can say that let us bring in this side, this and its minus will get cancelled. Angle AEB is equal to angle this one BAQ. Now let us see whether we have proved anything or not. BAQ we have got, but it should be angle ACB, not angle AEB. Okay, we have got AEB, this angle we have got, but we need this angle. Dear students, you know that. Okay, this is the segment, any segment. No need to draw always, you always remember that it is a segment. If you consider this angle or you consider this angle, these angles are equal. What is the reason behind this? Angles on the same segment are equal. You can consider here infinite number of angles. All the angles are equal here. All the angles are equal. So in place of AEB, let us write which angle? Angle ACB, because this is required here. Angle ACB equal to angle BAQ. Reason, since angles on the same segment you can even write are equal. So we have proved the first part. This part is proved. Now this is left. For that we have to rub this part. Now my beloved students, we shall prove this part. Okay, now how to do? Before starting it, we have to know one more property of circle. Okay, but it is a cyclic quadrilateral. We know that in a cyclic quadrilateral, opposite angles are supplementary, or in simply, if we want to say simply, the sum of opposite angle is 180 degree. So in this quadrilateral, cyclic quadrilateral ACBD, okay, let us write in cyclic quadrilateral ACBD, what is the sum of these two opposite angle? How much? It will be 180 degree. Angle ACB plus angle ADB is equal to 180 degree. This will be equation 3, because 1 and 2 already we have used. This is the property of, as it is cyclic quadrilateral. Okay, again Here we need this PAB, okay, this angle. I am rubbing all this so that it is easily visible, okay, this angle. What we need? PAB, this angle and this angle. What is their sum? 180 degree, because they form a linear pair. Angle PAB plus angle BAQ. What is their sum? 180 degree. Since linear pair, they form a linear pair. This is equation 4. This is 180 degree, their sum is also 180 degree. So from equation 3 and 4 we get, from equations 3 and 4 we get, what do we get? They are equal, okay. Angle ACB plus angle ADB is equal to this, angle PAB plus angle BAQ. Now my dear students, what we have to prove? We have to prove that PAB, this angle, equal to ADB, this angle. That means we have to remove this. Can we remove this? Yes, we can remove. You see, let us see. Let us write the left hand side. I will disclose it in the right hand side. Okay. In place of BAQ, what can we write? Angle ACB, right? Angle ACB. What is the reason? Since angle BAQ equal to angle ACB. See, now the thing is very simple. You will remove this from both the sides. So what we have got? Angle ADB equal to angle PAB. Thus we have proved the second one also. So let us write the last statement. Therefore, angle final statement, angle BAQ equal to angle ACB, we have proved, and also we have proved angle PAB equal to angle ADB. Proved. Alright, now let us move to the exercise. Now dear students, let us start our journey. We have taken the first question. Let us read the question. Show that the two tangents drawn from an external point to a circle are equal. The same question is there even in the general mathematics, okay, in the circle chapter. But here we want to prove it by the help of the theorem what we have done just now. Okay, with that theorem we will complete all the questions of exercise 8.1. So here what is said? Show the two tangents drawn from an external point. External means it is outside. The point doesn't lie here. Suppose the point is somewhere here. This is the point. Now from this point we draw two tangents. One tangent is here. We can say a tangent will intersect the circle at a single point. We have drawn one tangent. Okay, suppose this is A. It is joined here. Okay, then another tangent let us draw here from here. This point is B. This point is marked as B. This is the point. Now what we have to prove? Let us write to prove that these two, show that the two tangents drawn from external point to a circle are equal. That means these two are equal. We have to prove PA equal to PB. We have to prove it. How will do? Again we need a construction. Construction part comes. What we'll do? At first let us join AB. AB is joined, and here on this segment let us consider any point. Suppose this is Q. Let us join. Okay, I am drawing with free hand, almost straight, isn't it? Now how will do? Okay, at first let me write the construction part. AB is joined. AB is joined a point. Q is chosen and AQ, BQ are drawn. This part you can write in your own way. Proof. Now question is how we will prove this. Okay. Dear student, what was the theorem just now we have done? A tangent is there, alright. We take a chord AB. This angle is equal to which angle? It's alternate. This is the adjacent segment, this is the alternate segment. Here we take any point, this angle equal to this angle. So when we consider, suppose this point is A and this is B, okay. PAB, this angle, PAB, this angle will be equal to, it's here the angle made with the chord with that, and the tangent is this angle. This is the, this segment is the adjacent segment, its alternate segment is this. So this angle equal to this, so this angle will be equal to this, so this is Q. Got it? So here angle PAB is equal to angle AQB. How? We have to write the reason by alternate segment, in the short form written alternate segment theorem. Okay, this is equation 1. Also, this is very short, the solution is very short also. Okay, if we consider like this, now this one, this angle we consider, this is another tangent, this is another chord, okay. This chord makes this angle with the tangent. Now when we come to this angle, it's which one is its nearer one? This is the nearer one, this is the, this segment is the nearer one, so its alternate segment is this, so this angle is again equal to this angle. Have you understood? Okay, so here also angle PBA equal to angle AQB. Again the same reason by alternate segment theorem. Okay, this is equation 2. Now you see from 1 and 2, this angle is also equal to angle AQB, this angle is also equal to angle AQB. So from 1 and 2, from equations 1 and 2, we get, what do we get? They are equal because each is equal to angle AQB. Angle PAB equal to angle PBA. Dear students, you see, look at this triangle. This is A and this is B. Okay, A, B, this is P. Okay, this is B. Let me write nicely. Here this angle and these angles are equal. Angle PAB equal to angle PBA. What do you think? Obviously then these two angles are equal. The sides opposite to equal angles are equal. This is the theorem in a isosceles triangle. Therefore PA is equal to PB. Okay, thus we have proved it. We have to prove this one only, PA equal to PB. Okay, now we have taken question number 2. Let us read the question. Two circles touch each other internally at a point P. The chord AB of the larger circle intersect the smaller circle at the point C and D. Prove that angle CPA equal to angle DPB. Okay, dear students, it is a little bit hard to draw the diagram in the whiteboard. That's why initially we have drawn the two circles. Otherwise it is very time consuming for me. Okay, here let us go start the solution. There are two circles, they touch here at point P. Two circles touch each other internally at point P. Okay, now what is the next? The chord AB of the larger circle. Let us consider a chord AB of the larger circle. This is the larger, there are two circles, you can see this is the smaller circle, this is the larger circle. Larger circle is really large, is not it? Okay, we have drawn this is the chord AB. Okay, this solution is very simple. The chord AB of the larger circle intersect the smaller circle at the point C and D. This point is C and this point is D. Okay, so what we have to prove? Prove that angle CPA, that means this angle. CPA is this angle. Let us join CPA CPA is this angle. This angle equal to which angle? Angle DPP. DPP. Let us join them. Okay, we are joining DPP. Hopefully it is correct. Okay, yes. Okay, DPP. Now to prove this, we need a construction again. What we'll do in the construction, through the point P, let us take and draw a common tangent. That is, this tangent is for both the circle, smaller circle as well as for the larger circle. Okay, we have drawn a common tangent. We have to choose such alphabet which we have not used. Here we have used A, B, C, D, P. Then let us mark E and F. Okay, this is F. Okay, construction part. Through the point P, a tangent. What is the name of the tangent? EPF. Okay, F is not nice here, is not it? Let us write nicely. Tangent EPF is constructed or drawn. Okay, now let us start proving. Okay, now here how we'll do. Here you see, at first let us take the, okay, what is the theorem? That theorem we have to know again. This is the tangent, this is the chord. This angle is equal to this angle. Okay, so for the smaller circle, PC is the chord. Okay, let us write PC is the chord. PC is the chord here. So this is the angle formed, this is the angle formed. This angle will be equal to which angle? In the smaller circle. Please concentrate in the smaller circle. Do not look at the bigger one. This angle. So its alternate segment with this chord. This is the segment on the same side. Alternate segment is this. So this angle equal to this angle, is not it? This is on the smaller circle. Okay. So here it is. That thing is like this here. So if we make C in this side, C is in this side, D is on that side. Okay, let us make, so this angle equal to this angle, this angle equal to this angle. Angle with the chord and the tangent is equal to the angle on the alternate segment. So this angle equal to this angle. Let us write. So here angle EPC equal to which angle? Angle CDP. Angle CDP. What is the reason? By alternate segment theorem. This is equation 1. Understood? Now let us move to the, for the smaller one we have done. Now let us move for the larger one. Now for the, let us wrap this. Okay, you can, otherwise there will be confusion. Okay, for the larger circle, this is the angle made with the chord and the tangent. Okay, say this is, now let us change the name here. This is A for the larger circle. You consider the larger one, not on the smaller one. This is A and that is B. This point is B. You consider this chord and the tangent. This is the angle. This angle equal to this angle. Okay, I have marked with double arc. This is double arc. This is the, don't look at the smaller one, bigger one. This is the chord on the bigger circle. Okay, so this angle equal to that angle. For this chord, this is the segment, adjacent segment, that is the opposite segment. Also, angle EPA equal to angle, this angle, angle ABP. Same reason, by alternate segment theorem. This is 2. Okay. Now let us subtract them. Why we shall subtract? This question may arise in your mind, because we need, first of all, you see what we need. We need angle CPA. What is CPA? This angle. CPA, this angle. This angle means the bigger one. From the bigger one we shall subtract this, then only we will get. Now where is the bigger one? Bigger one is here and the smaller one is here. So to get this smaller angle from the bigger angle we shall subtract this. Okay. Now subtracting 2 from 1, we get, what do we get? Let us write. EPC is the bigger one. EPC is the bigger one. EPC minus EPA. Angle EPA equal to angle CDP minus angle ABP. Got it? Okay. Now here on the left hand side, EPC minus EPA. Obviously this angle, let us write angle CP. We are very lucky that we have got the left hand side, but we are not so much lucky that directly we will get the right hand side. CDP, this angle minus ABP, this angle. How come this angle now? Okay, what technique we have to use? You know that in a triangle, okay, let me write this, then you can easily understand. D, okay, this is B, this is P. This is the scenario now. Suppose this is A. This is the exterior angle. Okay, in this triangle, you look at triangle PBD. Okay, this triangle PBD. In this triangle, this is the exterior angle. Exterior angle equal to sum of two opposite interior angle. This angle equal to this plus this. So in place of CDP, sorry, let us write this angle CDP. Here only we can say CDP. We can write this plus this. What is the name of that angle? Angle ABP. ABP we can write. Why will write? Some of you will say, sir, I'll write DBP. Okay, correct. But here we have angle ABP. That's why we have ABP written, because we'll cancel this angle. Plus this angle equal this plus this. What is the name of this angle? This angle you can write according to this. We'll write this angle is DPP. This angle equal this plus this. We have written this. This one B is written. Now this. What is the name of this angle? DPP. Angle DPB minus angle ABP. Thing is very simple. What is the reason? By exterior angle theorem. Got it? Okay, now here we can cancel these two. So ultimately we have got, isn't it, angle CPA equal to angle DPB. Thus we have proof. This proof is very easy, isn't it? Now dear students, we have taken question number 3. Here two circles touch each other internally at a point P. This point P. Okay, let us mark this point P. If a chord AB of the larger circle, let us consider chord AB. Okay, anywhere. Suppose this is chord AB of the larger circle. Let us draw chord AB. This is chord AB. Okay, this A is not nice. Let's write A nicely. Okay. If a chord AB of the larger circle be a tangent to the smaller circle, for this smaller circle you can see that we have drawn in such a way that it is a tangent for the smaller circle at point C. This is the point C. Then prove that CP. Okay, this CP, what does it do? CP will bisect angle APB. That means these two angles are equal. We have to prove that these two angles are equal. This is the thing. Okay, so let us write to prove. What we have to prove? I hope you understood the question. To prove, what we have to prove? Angle APC equal to angle BPC. BPC. Again, you know that we have to need some construction. So let us write construction. Construction part. In construction part, what we will do? Two things we need. First of all, we will construct a tangent here. Okay, this construction will be a little bit big. Tangent is required. A tangent we have drawn at point P. Okay, let us produce it so that it looks tangent nicely, isn't it? Otherwise you will not be confused. A tangent is drawn. Then what we do? We join it. We produce it up to this much. Okay, I hope you understood the diagram. Suppose this point is marked as Q, P, Q, and this is okay. So let us write the construction part. A tangent at P is drawn and BA is produced. BA is produced to, okay, here a tangent at P is drawn and BA is produced to Q. Okay, this is the construction. Now let us prove. Proof is very simple. Do not worry for the proof. Dear student, in question number 1, I think we have done length of tangent drawn from external point are equal. Say this is PA, this is PB, these two are equal. So here we know, let us apply this theorem or this property here. We know length of tangent drawn from an external point are equal. So here for this smaller circle, concentrate on the smaller circle, there are two tangents. One tangent is PQ, another tangent is CQ. We know this, therefore what will write? Angle QP and QC. For this, here I am marking nicely so that you can understand. External point is Q here, one point is C, another point is P, so they are equal. We have written here QP equal to QC. I think you have understood this part. Okay, in this triangle QPC we have shown that these two sides are equal. So in a triangle, what is the name of the triangle? QPC. These two sides are equal, so obviously these two angles are going to be equal. So therefore angle, what is the name of the angle? Angle QCP equal to angle QPC. These two angles are equal. Alright, so here let us write QCP at first. QCP, okay, now QPC, you can see that QPC, this whole angle QPC, it is the sum of these two angles, is not it? One angle is angle QPA, this angle and this angle. Okay, so it is angle QPA plus angle QPA and angle APC. Angle APC, we have got APC, somehow we have got. Okay, then let us, here we have split it, we have broken into two parts. Let us break this also, QCP. So if we are lucky, we will get angle BPC here also, because this we may get this. Okay, let us see. Okay, how we'll get QCP, this angle. You see, my dear students, let us try to visualize this. What is the name of the angle? QCP. Okay, this angle is C. This is the external point QCP, this angle, and that is B. So we have tried to draw this BPC, and external angle is this one, QCP. So this angle equal to this angle plus this angle. I hope you are understanding. Okay, so this angle we can write, this is the sum of angle BPC, angle, what is the name of this angle? Angle BPC. We have taken BPC plus angle PBC. Angle PBC. Okay, this side let us write same. Here we have to write the reason why we have written. How can we write? By exterior angle property of triangle. Exterior angle property of triangle. I think I am little bit time, isn't it? Okay. Now, after that, APC we have got. Have we got BPC? BPC we have got. So we are very fortunate. What is our aim? We do not need this, isn't it? So let us remove this. How to remove? Let us see in the figure what are these angles actually. Okay, I am trying to rub all this. Okay. This angle we want to remove these two, isn't it? So how to remove? Let us mark these two angle in the figure. PBC. What is PBC? PBC, this angle. Okay, let us mark with a double arc this angle, and QPA, this angle. If you look nicely, then you can find that they are obviously equal. What is the reason? Now let us see what is the reason behind this. Thing is very simple. Let us draw a chord here, and this is the tangent. Okay, this is the external point Q. The tangent is at point P. Okay, this angle is equal to always this angle, you know it. Okay, so here this angle is, this is A and this is B. Okay, we try to visualize the same thing here. You see, the tangent is QP, the chord is AP. We are concentrating on the larger one, PA, and this the opposite angle is B. So this angle equal to this angle. Easily from this figure also you can say that this angle is equal to this angle. Alternate segment theorem. This is the chord. This is the chord. Angle formed with the chord and the tangent is equal to the angle on the alternate segment. Okay, so we can write. So angle BPC in place of PBC. PBC. Let us write angle. Here it is PBC. We shall write PBQ. PBQ. Okay, is equal to QPA. QPA. This angle is equal to this angle. We can write is equal to angle QPA. Okay, this angle we have marked with the double arc. This angle equal to this angle. What is the name of that angle? Angle PBQ. Okay, plus angle APC. What is the reason? By this in place of this angle we have written this PBQ. Again I repeat, PBQ. Why you have written? Because these two angles are equal. In place of angle QPA, this angle equal to this angle. By alternate segment theorem. What you do? From both sides you remove these two. Angle BPC equal to angle APC. We are supposed to prove this angle APC equal to angle BPC. Thus we have proved it. Have you understood? Now dear students, let us take question number 4. Let us read the question at first. Two circles intersect each other at 2 points A and B. These are the two circles we have considered. They intersect at the points A and at the point B. And a common tangent touches the two circles at C and D. Let us draw a common tangent. Common tangent means this tangent, a line which touches both the circle this circle at a single point and this circle also at a single point at C and D. So this point is C and this point is D we have considered. Now what we have to prove? We have to prove that angle CAD, that means this, we have to join this C to A, CAD, and first angle this CAD, okay, this is little bit rubbed, no problem, we'll correct it, and then CBD, this is CBD. Let us join with freehand diagram. Okay, this angle and this angle, that means this angle plus this CBD. Angle CAD plus angle CBD, their sum is how much? 180 degree we have to prove. Okay, so let us start. At first what we'll do, we shall start with the construction. Construction is that we shall join AB. Okay, this is joined, AB is joined. Okay, this is again, this is rough, this is the disadvantage of a whiteboard. Okay, AB is joined. Okay, now let us start the proof. Now here again, this question or the solution is based on the alternate segment theorem. What was the alternate segment theorem? We want to again know it little bit. This is a tangent. If we consider any chord, okay, if we consider this circle, CB is a chord, CB is a chord. Okay, this CB is a chord, we can see. Now here, this is the adjacent segment, this small part is the adjacent segment, and this is the alternate segment. In that alternate segment, there is angle is formed like this. That means this angle will be equal to this angle. Got it? So see this angle, that is the chord and the tangent, it makes some angle with this angle. Let us write. So here angle, what is the name of this angle? We shall write angle BCD. BCD is equal to which angle? This angle equal to this angle, because we are applying alternate segment theorem. This angle equal to this angle, equal to, what is the name of that angle? Angle CAB. Angle CAB. Here how we have done? By alternate segment theorem. Okay, also this result is for this circle. Let us apply the same for that circle also. Now in this circle, okay, this is the tangent and this is the chord with the double arc I am showing. Okay, is it visible? Okay, with this tangent the chord make this angle. So this, for this chord, this is the adjacent segment, this is the alternate segment. In this alternate segment, this angle is formed, so they are equal. So what will write? What is the name of this angle? Angle BDC. Angle BDC is equal to, what is the name of this angle? Angle BAD. BAD. Reason is same, isn't it? By alternate segment theorem. Okay, now you see, we want CAD at first, isn't it? We have to show that their sum is 180. We will get it later on, but at first we need CAD. Now yes, you see, CAD is the sum of these two angles. It means CAD means CAB plus then BAD, these two. Then what we have to do? We have to add them. Now adding the above two result, we get, what do we get? The solution is very simple. Just let us add BCD plus angle BDC. What is the sum here? Angle CAB plus angle BAD. Got it? Okay. Let us elaborate a little bit. Let us add them. Angle CAB plus angle BAD, their sum is angle CAD. Angle CAD. Okay, this one we have obtained. Now we have to obtain CBD. Okay, we'll obtain gradually. Okay, what we try to do, let us try to draw this triangle CBD. This is C, this is B, this is D. Okay, my dear students, what is the sum of these three angles? We know that sum of these three angles is 180 degree. This is the angle sum property. Here you see BCD, this angle, BCD, this angle, plus BDC, this angle. Here it is the sum of two angle is given. So if we want to write like this, angle BCD plus angle this one BDC, plus if we take one more angle CBD, what is their sum? Their sum is 180 degree. But if we want this, that means if we want angle BCD plus angle BDC, if we want that their sum is 180 degree, this angle we shall take on the other side, it will be minus angle CBD. Got it? Is it okay? Okay, so in place of this, let us write, okay, this one we shall substitute. How will substitute? We shall write 180 degree minus angle CBD. What is the reason behind this? Here we have used the angle sum property of triangle. Angle CAD. Reason you write by angle sum property of triangle. Got it? You see, the thing is very simple. Now I hope all of you understood how to do. Okay, what we do, we need CAD plus CBD. This CBD must be plus, that means we have to take this on the other side. So in this side, let us write 180 degree, then this angle CAD, alright, plus this is minus, on the other side it will be plus angle CBD. Now I think we have obtained. Let us write according to the demand of the question, angle CAD plus angle CBD. What is their sum we have obtained? 180 degree. You see, the proof is very simple. Got it? My beloved students, we have taken another easy question. This is question number 5. Let us read the question. In triangle ABC, AB equal to AC. Okay, here this is the triangle ABC here, AB is equal to AC. This is given. Show that the tangent to the circumcircle. Okay, do you know what is circumcircle? Okay, briefly I am saying is a circumcircle means if a circle passes through all the three vertices, then it is called circumcircle. Another type of circle is there which is related to triangle, that is called incircle. Incircle means it is a circle which passes through all the three sides. It will just join or just touch all the three sides. It will be in the interior of the triangle, that is incircle. Okay, let us come to the point. This circumcircle of the triangle ABC at A. Okay, tangent we have to draw at the point A. Let us draw a tangent here. This should be parallel, they have said. Okay, let us draw it. Okay, suppose this is P and here we mark this is Q. Okay, again let us read the question if you did not understand. In triangle ABC, show that the tangent to the circumcircle of the triangle ABC at A is parallel to BC. What we have to show? Let us write to prove. We have to prove that this tangent PQ must be parallel to BC. Okay, so let us start our proof. Okay, now again, what concept we shall apply? Again the same concept. What is the concept? This is the chord. It is A here. Now if we take B, okay, so this will be equal to, this angle will be equal to this angle, alternate segment theorem. Okay, this angle. Okay, so here it is ABC, AB then C. Here we have to write P. Okay, let us apply this. Here what will write? This is very simple. You will find this angle. Let us take, all right, this angle equal to, you see, if you didn't understand this part also, no matter. This is the chord. Its adjacent segment of this chord is this one. Its alternate segment is this one. Okay, so this angle is equal to the angle on the alternate segment, this angle. Got it? So let us write here angle PAB is equal to which angle? Angle ACB. Angle ACB. Why? By alternate segment theorem. Okay. Now, but here you see what is one more information is given. This one we shall use. AB equal to AC. If these two sides are equal, so we can write these angles are also equal. Can you write? Yes, because we know that in a triangle, okay, in any triangle ABC, if these two sides are equal, their opposite angles are also equal. So let us write, but angle ABC equal to angle ACB. Why? Since AB equal to AC. So now let us compare these two. So from above two results we get, you see my dear student, angle ACB is this one, angle ACB also is also equal to this one. So we can write therefore this equal to this. We get angle PAB equal to angle ABC. Okay, this result. Now look at the figure carefully. Angle PAB, this angle, PAB is this angle, angle ABC is this angle. Now here if you look carefully, here it looks like this. This angle is equal to this angle. What type of angle these two are? These two are alternate interior angles. If alternate interior angles are equal, then lines are parallel. Okay, so let us write the reason. But they are alternate interior angles, so lines must be parallel. That is, which are the two lines? PQ is parallel to BC. This thing we had to prove. So let us write proved. Have you understood? Dear students, let us, in this part of video, let us do up to question number 5. Okay, then from question number 6 we will upload in the next video. Okay, thank you.